Hi, good morning, good afternoon and good evening everybody joining around the world. Welcome to Selko's Global Mycotoxin Review. Today we are gathering with hundreds and hundreds of people from the global industry and we really want to welcome all of you to this live session. My name is Marcella and I will be your host for today. And I would like to explain you a few small things before we deep dive into all the matter. First of all, it's possible for you to ask questions. You can do this by entering the questions in the questions box that you might see next to the live stream. If you have made the live stream completely fill your screen, you might need to reduce it. And then you can see the question box and type your questions. And we will try to address as many as possible in the live stream. When you type your question, you will not yet see it in the live stream because we are expecting you really to enter a lot of questions and we will be selecting the lucky few to address in our webinar. So, with that, if you are on your mobile phone watching us today, there's also a possibility to ask questions. On the top of your webinar, you can see on the right a blue button that says questions. If you go here, you can type your question and we will try to address it in the live webinar. So these were the things I would like to address with you. You see this nice row of gentlemen right next to me. Let me introduce them to you. Let me just quickly go from my side along the line here. On your right, on my left, we have Mr. Pedro Carmona. He is the Global Business Director for the Feed Safety and Quality Program of Selko. Welcome, Pedro.
Yes, thank you very much, Marcel. A pleasure to be here.
And next to Pedro, we have Dr. Swami Haladi, and he will be doing mainly the big chunk today of the presentation. He will be telling you all about mycotoxin data review. So Swami Haladi is our Global Technical Commercial Manager for the Mycotoxin Risk Management Program. Welcome, Swami.
Thank you, Marcel.
And last but not least, on the end here, we have Mr. Avinash Bhatt. Avinash is the technical specialist for mycotoxin analysis at MasterLab, and he will come back at the end of the webinar for our Q&A to address those really technical questions that really go into the data, because he worked together with Swami to gather all this data and to make them visualize them for you. So any really technical data questions, Avinash is here to help us. Welcome, Avinash.
Thank you, Marcel.
So before we move to Swami, I have a few questions for you, Pedro. First of all, we are having this webinar today and because we are gathering a lot of data, but why is Selko actually gathering this data? Why is it so important to have this global database?
Yes, thank you very much, Marcel. And first of all, welcome you every single one of you that is around the world watching us. So we are very passionate about this topic within Selko. It's an area that we've been developing for several years. And mycotoxins are really impactful from the feed to food chain. So therefore, it's very key for us to also contribute to this topic in terms of bringing information on. When you look at the sort of areas that we're looking into and why this is relevant to us, starts with the insight. So we want to know from every year what is the relevance of mycotoxins across the world. We want to understand and share this information throughout the chain. For us also, having this knowledge allows us to make strategic decisions, either at the procurement level, on our organization or with our customers' organization, either with the QA, for example, and also with the formulation managers that we have on staff. Secondly, we also look into understanding and developing new solutions and implementing those solutions across the board. It's really important to have this information as a backup for that. And lastly, modeling. So more and more, this is certainly a trend that we see in the future. That's when we have big data and we are able to understand this data and the main trends, we're able to model for solutions and be more proactive than reactive.
Okay, and when it comes to this modeling and this generating of this database, what makes this monitoring program so unique?
Yeah, so a very good question. I think especially the areas that we focus on within Selko make us quite proactive. So it is quite unique on the fact that we have real-time data. So we have around 200 different input sites for mycotoxin analysis across the world. And that really makes us, on a 24-hour basis, understand what the reality is. So it really can make us proactive.
So they are really in the field?
Indeed, indeed. So our instruments, and of course we collaborate a lot with other institutes and universities as well in collecting data, but our sites are set to be in the customer or in our own sites in Utrecht. Therefore, we get really real-time data. And this program is also integrated in our global mycotoxin risk management program, which really makes this unique. So we are not only talking about solution-based, but part of the solution is also the analytical methods we use.
Here you are mentioning Nutreco. I know Selko is the feed additive brand of Nutreco, and you were also explaining about that we need to get these insights when we gather this data for our own purchasing of grains. Why are we sharing this with the agricultural community now? Why do we share this data with you guys?
Now, I think, again, a very good question and something that's triggers. So we feel that we're part of the agriculture community in its sense, and certainly mycotoxins have that challenge where a lot of different companies or different universities are collecting their own data. But what we believe is that we should be able to share this data to have a bigger picture and a better understanding what the challenge is actually in a global scope. So it is one of those areas that big data really makes an impactful. And as you'll see today, we'll look at trends, and it's only possible when we have large amounts of data that can really reduce the amount of layovers that we have, or layouts that we have, but really trying to see main trends and help our customers that way.
I can imagine also when we try to mitigate mycotoxins in the industry overall, it's important that the industry is aware of the risks so we can also advise them better. I can imagine that would help as well.
No, indeed. I think looking at examples like the pro-risk feeds that we are working with, so different partners in the organization, but also with other colleagues in the industry, trying to get this data in one location so we can really contribute highly to solving this challenge that we see facing the feed-to-food chain.
So before we really deep dive into the data, can you already explain a little bit about some of the global trends that are really relevant to this mycotoxin data?
No, absolutely, Marcel. Obviously, the topic of mycotoxins is there since the 40s, more or less since 40s, 60s. We start doing a lot of digging in, but the main trends at the moment is really looking for the impact of climate change. So, of course, this is really a global trend that we're following very closely. It really deeply impacts the sort of mycotoxins regionally that we find, but also that changes from year to year. So we really need to be paying attention to be able to be more proactive rather than reactive. So as an example, you see that we have 3 years, consequent years of La Niña. That affects, of course, in some areas of the globe, we get better yields and better production because of rain, but we are on the 3rd year consecutive La Niña, which affects a lot of the yield in high-producing areas like Argentina or southern part of Brazil. So it's very important to look at those trends. Also, the development of rapid methods of analysis. So we have now the trend going into more that sector, and not only looking for accuracy, but methods that are quite reliable for us to be able to do more predictive and reactive sort of strategies. And then I would say storage improvement is key as well. So we see more and more customers, either at large scale or small scale, really looking at improving their storage, because we see mycotoxins coming from the field, but then really growing in storage in some cases, Swami will discuss. So it's all about predictive models to try to help us understand how we are going to be able to be more predictive and more
I can imagine, so we can be ahead of the problem more or less.
Indeed, I think that's key for us and for our mission of feeding the future.
Yeah, I understand. Thank you so much, Pedro. I would like to go and move to really the big part of our webinar. So thank you, Pedro, for your information.
Thank you, Marcel.
Again, welcome back to all of you. Especially this session is for Asia and Africa. Of course, I start the presentation with a global overview of what's happening in 2022 and outlook for the 23. And I think most of you are following us for the last 4 years or so. We have been doing this continuously, as Pedro mentioned, to provide information to take proactive steps in managing the mycotoxin risk. So I think the viewers know very well about mycotoxins. I really don't want to get into the details, But of course, you have mycotoxins, which are mainly divided into four aspects: Fusarium toxins, Aspergillus, Penicillium, and ergotoxins. And those which are indicated there in red are the ones we generally analyze. But of course, we know that there are more than 600 mycotoxins that are out there scientifically evaluated in some, at least in the research setup. And we do know that there is a question of masked mycotoxin, emerging mycotoxins coming into this picture, complicating already a complex issue of mycotoxins. So again, an integrated approach is very much important for managing the mycotoxin risk. And if you look at the the diagram here, very clearly showing collecting the raw materials or the feeds from different feed mills or the integrators, and analyzing them would help in, of course, a proper quality control, feed raw material supply, and feed formulation, as Pedro was mentioning, because sometimes some parts of the world in some years you have levels of vomitoxin as an example, much more than what the animals can manage. So you really need to formulate in a way that to the level of inclusion of these raw materials so that it doesn't cause problems to pigs, poultry, and dairy. So the good thing is that the information coming through these rapid analytical tools, but also we use HPLC, we use ELISA, these all different techniques, all the data coming into one database. We use that to the webinars like what we are presenting to you today for educating the industry. We write a lot of articles for the education purpose. Also, it gives you an idea about mycotoxin monitoring and advice specific to a particular problem the customer is facing. So before I actually get into the data, these are the terminologies that I would like to set up a call with because I think these are very, very important for us to understand. Whenever in the presentation I talk about percentage contamination, it means the percentage of commodities what we have tested that contain mycotoxin concentration above the limit of detection, what we call LOD. And when I talk about concentrations in parts per billion, I would be talking about micrograms of these mycotoxins per every kg of commodity, whether it is raw materials or feeds, and that is above LOQ and taken out of positive samples. That means you have a set number of negative samples, and then out of the positive samples, actually what would be the average median concentrations of various mycotoxins, which you will see in my presentation. Parts per billion ppb, we represented. I know some toxins like DON and fumonisin are usually mentioned as parts per million, but to keep it uniform, we keep all the presentations, throughout the presentation, mycotoxin concentrations as parts per billion. So also, if you look at the description of various commodities we are using, whenever I say grains, it refers to all types of grains that are intact. That means there is no further processing, like wheat, barley, corn, so without the processing. Grain byproducts would be some commodities that are originated from grains that have gone through some sort of processing. So of course, you have more fiber content in there. The potential of mycotoxin accumulation is quite high there. Protein meals, we refer to the commodities that contribute significantly to the protein percent, and that gone through some kind of solvent extraction procedure. So all the meals will come into this picture. We are including the animal origin meals like meat compound meal, fish meal, etc. in this category. The other protein products, all other protein sources than the meals, other than the meals, because sometimes we get the samples which are full fat soya, which are soybeans as such. So those would come into those categories. So this will nicely set up when I'm talking about various raw materials we have been testing. So what we did in 2022, we have analyzed more than 50,000 samples from 42 different countries, as you can see in the slide. And raw materials represented about 64% of this total analysis, and about 36% were complete feeds, as you can see in the picture. These are from 42 countries. You can see the different countries I mentioned there, starting from Europe all the way to Asia, various countries contributed, of course, different levels of different numbers, with Europe being the number one, then the North America, then Latin America, Africa, and Asian region. Of course, we are expecting higher samples from Asia in the coming years. A small group we have made, by sample group, feeds, grains, grain products, protein meals, silages, and unspecified samples, feeds being the number one. Because I think one of the objectives of analyzing the mycotoxins in feeds is to actually understand the toxicity of these mycotoxins in various feeds. Because we all know that the way the poultry will respond to vomitoxin, for example, is different than how a pig would respond. So that's why it's very important for us to understand not only feeds, but within the feeds, different types of feeds like pet food or poultry feed, the ruminant feed, how they respond with the mycotoxin levels is very important. And then we have the various grains, grain byproducts. Grains would be the number two in the number of samples we have analyzed. In terms of the sample details, I am not going through in detail here. You can see that various numbers of various types of raw materials we have tested, starting from maize, all the way to the groundnut meal, and then various feeds, including pig feed, layer feed, broiler feed, silages also. In some cases, we have analyzed both the grass silage and the maize silage. So now I take you to the global data analysis. Just for your clarification, when I am talking about global data, that means I have included all the raw materials in there, all the feeds in there, and from all the regions in the world, all the 5 regions which I mentioned earlier. When you look at this entire data set, what we observed in 2022 is that the T2 was the highest percentage of contamination. That's a bit of a surprise to us, because T2 is not a very common mycotoxins. Generally, we see in the previous years, but I think due to the climate changes, due to the Fusarium sporotrichoides, which is a particular fungus, Fusarium fungus that produces the T2 toxin, might have gone at the right conditions for the growth in the 2022. So we 69% contamination with T2 toxins, followed by aflatoxins, zearalenone, and then ochratoxin at 31%. And this bit of definitely surprising, because not only from the point of production of this toxin, but T2 is a very toxic to most of the animal species, especially ruminants, poultry, are quite sensitive to the T2 toxin. So we did see a significant challenge there. And then, of course, you can also see the average and the median represented in the column number 5 and 6. And you can see that there is quite a bit of variation between the average and median. And it's more than 50% of variation between the two. And the median is more than 50% lower than the average. And the highest variability we saw was for aflatoxins. As you can see there, the median was 3 ppb, whereas the average was 13 ppb. Again, like last year, what we mentioned, it's very important for us to look at not only average, but look at the median. Because the problem with average is that high levels of a particular few samples. For example, in this case, we saw 3,400 ppb of aflatoxin. That's a very, very high level. So if you have 5 or 6 samples in that range, you are already increasing the average. So that's why we feel median is a better way of expressing the mycotoxin contamination in terms of the concentrations. So it's a very busy slide, but you can see there to varying degrees, various commodities have been contaminated with mycotoxins. And we see the grains, pretty much all the mycotoxins were present, with ochratoxin being around, I believe, the lowest, around 27%, but rest of them were quite higher than that. The protein meals as well, we see aflatoxin, zearalenone, and silages and byproducts were the most contaminated. It is expected due to their byproduct nature, they tend to contain more toxins. We had quite a high levels of aflatoxins, DON and zearalenone in these samples. So this is something for the entire samples instead of only giving the averages. So you can see in this picture, the distribution range of mycotoxin concentrations. Just want to set the slide for you. If you just look at aflatoxin there on the left-hand side, and you can see there that we divide this into box into five different quadrants. The top one is we call as the highest number or the maximum number, then followed by the third quartile. Then we have the median in the center, and then we have the first quartile, and at the bottom you see the minimum number. So anything that's outside the maximum number and the minimum number, we consider it as the outlier. And so that's very clearly showing the distribution of mycotoxins in various samples, not just the average or median. You can see the scattering. The higher the density means more number of samples you are having. And same way you can look for DON, fumonisin, ochra, T2, and ZIA in this slide. And one thing you can clearly notice is the difference between the median and average in aflatoxin is much different as compared to that of other toxins. And so where in DON and fumonisin, you tend to have a bit more closer between the median and average as compared to that of aflatoxins and ochratoxin relatively. So if you start looking at individually all the mycotoxins, for example, aflatoxins in this case, various commodities wise we look at, we saw a median for the feed containing very higher levels of aflatoxin as compared to all other raw materials, because we know that feed has contained multiple ingredients which may be contributing to the mycotoxins. And if you look at the ochratoxin, we saw the median of 6 for protein meals. That's a bit of a surprising as well, but this again shows that we need to be careful about protein sources and not only looking at the energy sources for mycotoxins. When it comes to T2 toxin, we again, protein meal contributed the highest median of 25. And for the fumonisins, we saw the feed, of course, representing the highest median of 1,020 parts per billion. So again, I think depending on the types of ingredients we are looking at, the mycotoxin profile can vary. When it comes to DON, that byproducts seems to have a higher median of 749 as compared to the other raw materials. And finally, for zearalenone, animal proteins, that's a bit of a surprise to me. Generally, I don't consider animal proteins, animal products, that means meat meal, fish meal, contributing much to the mycotoxins. It's maybe an aberration, I'm not sure, but we did see higher levels of zearalenone coming from the animal products. It can explain to some extent because zearalenone is a lipid-soluble mycotoxin, so there can be possibility, but I think maybe you need to look at more number of samples to see whether it is really a fact or just an aberration. So we all know that maize, corn is the #1 raw material we use across the globe, whether it is poultry diet, pig diets, and even in the ruminant diets. And what we are seeing here, again, the average, the median for aflatoxin around 3, and DON over 700 parts per billion, fumonisin 900 ppb, ochratoxin 3, T2 18, and zearalenone 57. Again, you can see the difference between average and the median is quite high, similar to all the samples together we put together for maize. So these kind of analysis will help us to understand the moderate toxicity that can be caused by these mycotoxins to various species of animals. So what about the complete feed? I think we all know that this complete feed analysis is a bit tricky because when it comes to the feed, you have different raw materials inside. Whereas when you're looking at raw materials, it's a bit easier. You can standardize, you can validate your methods. When it comes to feed, depending on the composition of the feed, depending on how much corn you're using, depending on how much wheat you're using, or soybean you're using, the analytical validation has to be improved, and of course, feed is what we are feeding to the animals, right? So it's important from the point of understanding the toxicity to animals. I believe more in looking at the feed rather than looking at the raw materials. And the raw material analysis is good for quality control, but feed is the one actually indicating the amount of toxicity. So if you look at poultry feed, we have divided the poultry feed in this case into broiler feed and layer feed. The aflatoxin are similar in both these feeds. The median you can see there, and in case of Dawn also quite similar. Whereas in fumonisin we tend to see a little higher concentration of broiler feed. I think that's reasonable because we know that fumonisin mainly comes from corn. And in broiler feeds, we use more corn. So we can expect higher fumonisin coming from the broiler feed as compared to that of the layer feed. And if you look at ochratoxin, it's quite similar. And then in T2 toxin in layer feed is a bit higher. I think, again, that gives a bit of a clarity because our layer feed has got a lot of byproducts. When you start using byproducts like DDG and various other products, you tend to have more T2 toxin coming in the layer feed as compared to the broiler feed. And finally, Zaralanan is quite similar, both the poultry feeds. Swine feed, we looked at pig feed for the fattening, the grower finisher. We looked at piglet feed. We looked at sow feed. And I think you can see that in case of piglets, the aflatoxin level is a bit higher side here. And whereas the Dawn level is pretty similar in all of them. The fumonisin, we tend to see less of these toxins in case of piglets. I'm sorry, I think the aflatoxin is more in the fattening pigs, which is understandable because we usually tend not to give too much attention to the grower finisher pigs. We use a little less quality raw material, so that's why it's expected to see higher aflatoxins. Whereas piglet feed, we are a bit more careful. We are using better quality raw materials. That is kind of reflected pretty much throughout the slide. Relatively lesser amount of mycotoxins coming in the piglet feed than the other two. Pet food, of course, we don't have a lot of numbers there. But again, aflatoxins we saw can be a concern. And we had Dawn in the vicinity of around 1,700 to 1,000 parts per billion. Fumonisins were there, ochratoxin, T2, as well as Zaralanan. So certainly, pet food is something we need to be quite concerned about the mycotoxins. Ruminant feed on the right-hand side, if you can see there, aflatoxin again, there's a bit of a variation there. It's kind of expected. And we see Dawn, fumonisins around the same level, ochratoxin similar to the aflatoxin levels, and T2 Zaralanan is relatively high. And we know that ruminant animals can be quite sensitive to T2 toxin and Zaralanan, both at the reproductive level for Zaralanan and at the intestinal level for T2 toxin. So since the audience this morning are more concerned about the raw materials and feeds in the Asia and the Middle East and Africa, I will tend to go a little bit more in detail about these two regions. And as you can see in the slide, Africa and Middle East, or MEA we call, we have a relatively less aflatoxin issue than Asia. But you can see both Dawn and Zaralanan levels are a bit higher in Africa and Middle East. And this can be easily explained because in Middle East and Africa, you import a lot of raw materials from some North America and other regions due to the lack of locally available raw materials. That's why you tend to see more of these challenges coming from the imported raw materials. The fumonisin is higher in Asia as well, ochratoxin, and T2 is a bit higher in the Africa and Middle East. So fusarium toxin tend to be a bit more higher in the African Middle East because not from the local raw materials what you're using, but the imported raw materials coming from North America and probably in some parts of South America as well. So what about the distribution of aflatoxins in these two regions? If you compare Africa and Middle East, an average of 14, and whereas in Asia is 36 parts per billion, so it's a bit higher as expected. And the same thing applies for the ochratoxin. This is not surprising because Asia tend to have more aflatoxin and ochratoxin issues. And as I mentioned, the T2 levels seems to be a bit higher, and as well as the, I think in the next slide you will see DON and zearalenone levels are also a bit higher in the Middle East, African Middle East, for the same reason I mentioned before. But the fumonisin is a bit higher in the Asian region. And also look at the median and the average. So quite a bit of a variation there as well. So it's very important that we look at both median and average, not just the average. So as I mentioned, DON seems to be a bit higher, zearalenone also in case of Middle East and Africa. So one interesting thing we actually looked at this year, a bit more than the last year, is looking at seasonal variation in mycotoxin concentrations. I think this is very important for the fact that month-to-month variation of these mycotoxins can also give us an idea what kind of growing conditions we had in those months in different parts of the world. So if you look at this slide, and again, we're thankful to Avinash for looking into expressing these numbers from various ways. In 2022, when you look at the total data set, we had aflatoxin relatively lower levels in the beginning of the year, and somewhere in June, July, it's peaked. And again, probably somewhere in November, started declining again. So it does correlate with the problem in Asia we are facing, problem in LATAM we were facing. And also this year, we did a bit of a higher concentration coming from Europe as well. So just remember that this is the old set for the global, so we don't really differentiate between the regions. But if anybody is interested, please let us know. We can always do more analysis and send to you to look at what happens to these in particular regions. And DON again starts high in the beginning of the year and then started going down. And fumonisin, you can see exponentially going up from January to December. Ochratoxin is quite flat, and we do know that it's generally less concentrations, but it's quite flat throughout the year. T2 toxin has a curve that started high, coming down in the middle of the year, again going up, maybe due to the dry conditions, or we know that T2 is produced by a different fungus, and that is something we need to really keep in mind. All the fusarium fungus doesn't need the same conditions for mycotoxin production. The conditions that are required for the production of DON and zearalenone are different than the conditions required for T2 and the condition required for fumonisins. So that is we should keep in mind. And as the weather pattern changes throughout the year and different regions, we can see the T2 toxin changing as well. And finally, looking at zearalenone, again, different peaks somewhere around August and started declining. So this gives a very nice overview. If you start digging deep into maybe we can correlate with the weather, we can correlate with the import, export, storage. So very nicely come together for us to understand, well, there may be reasons, there may be the ways we can manage, predict the challenge better than what we are doing at the moment. So what about the different regions? As I mentioned to you, we start looking at Africa, Middle East, Asia, Europe, Latin America, North America. You see the aflatoxin, in the light green, I believe. So you see a different pattern there. But look at in Europe for aflatoxin. It peaks somewhere between May and August due to a number of reasons, and in LATAM, sorry, and then it kind of comes down. So one thing you see across all these slides, the variability of mycotoxin concentration is much higher in LATAM as compared to other regions. It may be due to the importing of raw materials in countries like SCA, and maybe the local raw material in Mexico, local raw materials in Brazil. All these are giving different dimensions in terms of mycotoxin concentrations. So if you look at North America, you kind of see a consistent aflatoxin level coming there. In some years you can see high, some years you can see low levels of aflatoxins in North America. If you look at the DON levels, I just want to inform you that DON is not very regularly analyzed in Asian region. So that's why you kind of see a flat, and probably that's not very reflective of what's going on in the field. I believe in Asia, we need to do more and more analysis of dawn to get a better picture. So that's why it's kind of look flat throughout the year, which I believe probably not a true representation of the issue we are seeing at the moment. And Latin America, again, is a bit on the lower side as expected, but different patterns you can see there. Zaralanan, and it's very interesting. For me, I always believe that dawn and Zaralanan comes from the same fungus, Fusarium graminearum. But when I started looking at these pictures, I do believe that maybe Zaralanan, maybe some other funguses can also produce Zaralanan, because the pattern doesn't exactly reflect the dawn concentrations. And if you look at there again from North America, it's a very high levels in the beginning of the year for Zaralanan, and then started declining. And Europe is quite flat, throughout the year. And for Asia, again, a pattern of higher levels initially, then coming down and increasing again. So very nice pattern to see and analyze the challenges. So T2 toxin is something we have seen this year, a bit of surprise. In North America, we saw pretty much more than 90% of the raw materials and the feeds we tested had the T2 toxin. So, and we know that North America exports a lot of raw materials. So in the rest of the world, should be concerned about that. Of course, already you might have experienced the problem, but you do have some of these raw materials stored for the use in the first quarter or up to the second quarter of 2023. And then you see the fumonisin behaving erratically in Latin America. And I don't really know what exactly, so we need to correlate them. But again, I think the local raw materials are contributing significantly to these fumonisins. And then there is a significant increase in Asia as well, whereas as the year goes, the fumonisin levels increasing. So I think by looking more deep into these numbers, I think we get a clarity on what may be the reasons, what are the conditions that are actually influencing the variation in these numbers. So if you look at the 2021 and 22 comparison, as I said to you before, we have been analyzing these for the last 4 years in a bigger survey. Of course, we had analysis in the past as well. So we are looking at various mycotoxin levels for the last 4 years or so. Compare 21 and 22, you see a very flat line in 21 for aflatoxin, a bit higher levels, but you see in the 22, the pattern is quite different. For maize, now I am talking very, very specific to maize, because that's the major raw material we are using. And so the variation in maize in 2022 is much higher. So very difficult to predict, and you can see in some places, it gone up to more than 20 parts per billion, which is not good, particularly for dairy industry. If you look at dawn in maize in 21, you see a different pattern as compared to what we see in 2022. And the same holds good for fumonisin, completely opposite. So, maybe the weather conditions are changing in these places, and, we need to keep an eye. This very clearly shows 1 year you may have, let's say in 2021, you had more of a problem of fumonisin in the beginning of the year, and maybe in 22 you have problem in the later part of the year. So due to number of reasons, due to the flow of raw materials from place to place. Ochratoxin, kind of similar, but again you see the difference in 2 years. And T2 toxin, a completely different situation, because as I mentioned to you last year, it was not a major problem. And this year we see in maize, especially in the beginning of the year, quite high, and then kind of dipped down due to the dry conditions, and then again started increasing. And Zia, you can see the pattern as well. So if you look at Zia and dawn, the pattern is not same. That's what I was mentioning. Probably I need to upgrade myself, and what other fungus may be producing Zaralanan. We do see Zaralanan sometimes in the storage, the levels increasing, but that is something we need to look at further. So finally, the last part, of course, we've been talking about the challenges, and as Pedro mentioned in the beginning, we need to really proactively looking at all these mycotoxins from levels in different raw materials, not only us but different stakeholders in the market, and be proactive to manage the levels because we all know that prevention is better than the cure. So if you try to reduce the fungal growth in the raw materials and in the feeds, I think we can definitely have a significant impact in lowering the mycotoxins in the complete feed. So unfortunately, it's not new. We all know that there are multiple mycotoxins. We are only scratching the surface with 6 mycotoxins. But we do have more than this, and science has proven that very clearly. So when these mycotoxins interact with each other, you need the multiple modes of action. This slide, I think it's one of the very common slides used in many places. On the right-hand side, you will see a very good interaction between various mycotoxins, not just the conventional 6 toxins, but others as well. And so when they interact, there can be additive or synergistic effects. And those effects can happen at levels which are less than what it can be caused by the individual mycotoxin concentrations. So we also have to look at masked mycotoxins and emerging mycotoxins, which is a big challenge. And I think we know that a lot of research is going on these areas, especially in Europe. We need to look at that. What about the nutritional status of the animal? And farm management conditions also have additional factors, because many times I visit the farms, there can be a farm with the same raw material, same feed is going, 2 farms, but the management of one farm is better than the other. So the animal can manage the mycotoxins better than the other farm. So all these has to be taken into consideration. One interesting thing in recent scientific evidences also shows that we all know that duration, longer you feed, you have more chronic toxicity. But also the sequence of mycotoxin exposure play a role. That means whether the animal is exposed to T2 toxin first, and then the DON, or DON first, and then the T2 toxin, or DON first, and then the aflatoxin. The sequence of exposure will have an impact on the kind of outcome, the toxicity outcome we can expect. So that is why we also have a species risk assessment tool where you can have different mycotoxins. We set up the practical guidance values. We look at various species, as you can see, dairy, poultry, piglets, and sows. If you look at it individually, aflatoxin seems to be pretty much a challenge across all the species due to a number of reasons. And then, of course, DON in the last year, a bit of a medium risk. But one thing we're really looking at is how do we factor all these individual toxicities into the mycotoxin interaction. That is something we are working on in developing a nice model for poultry, pigs, which is almost ready, but for dairy we are still working on in developing this the toxicity models so that individual toxins are considered separately, but again in association with other mycotoxins to express this toxicity. So why do we need the multiple mode of actions? Just to give you an example of various toxins, how they affect various organs, right? So if you look at aflatoxins, mainly we know that they affect liver, kidney, and immune system. Those are the target. So, and aflatoxins, we also know that, the good quality smectite, bentonites binds very well. So binding is good enough for that. But if you look at ochratoxins, again, it affects kidney, gut, and the immune system, but there is only a moderate binding to these bentonites. So we kind of need other methods of other ingredients which improves maybe the kidney function, gut protection, immune modulation. Those becomes very important. T2 toxin, it affects the gut and immune system primarily. So again, there we need to look at, there is a moderate binding, what other options of improving the immune system, gut production plays an important role. Zearalenone, we all know that it doesn't affect much of other organs. It's primarily the reproductive system. So good that some bentonites do work at moderate levels of binding to these. But what else with the new technology? What else can be improved? What other biochemical pathways or toxicity pathways we look at, and making sure that zearalenone is not impacting the reproductive system of the animals. Fumonisin is a bit of a wide range of organs it is affecting, liver, kidney, gut, immune system. So I think that's, again, how do we improve these functions, liver function, kidney function, gut protection effect, immune modulation, all these needs to put into a picture with the fumonisins. A number of cases have been reported where high levels of fumonisins causing diarrhea issues. So, how that can be minimized is something we need to look at. So DAWN, again, affect the gut system and the immune system. And, protecting these are very important, especially in poultry, because poultry doesn't show very obvious challenges like feed intake issues, what we see in pigs. So it's important that, we look at what other ways we can modulate the immune system and the gut health. So that's the reason why in Trau, Nutreco, Selko, we are looking at that mode of action of toxo from all these perspective, looking at oxidative stress, looking at, immune system, gut wall, the binding, and of course, more and more research we are working on, looking at other biochemical pathways that we can influence so that the toxicity of the animal is less than what is possible without feeding these components. So I think that's a lot of exciting stuff coming in the future for us, along with what we are already doing. So with that, I would directly conclude that more than 50,000 samples have been analyzed. In 2022, we revealed that somewhere between 31 and 69% of the mycotoxin contamination for various mycotoxins. And again, we looked at the limit of detection quite seriously in these cases. Also, it is expected that aflatoxin was a major contaminant in Asia, while fumonisin showed the highest contamination in Latin America. So those two are pretty much in line with what we know. And interestingly, North America showed the highest contamination for all other 4 toxins we have listed here. And I think that's what is very important for regions like Africa or Asia. You're importing raw materials from North America. So you need to look at the challenges coming from these regions along with the challenges what you're already facing, locally, of course. So the median mycotoxin concentration, myself, Avinash, we as a team, we believe that is a better representing the field challenges because a few samples with very high concentration can actually skew the average, and which can give us a realistic risk, which probably is not there. So we need to be very careful about not overblowing the challenge. The evaluation of monthly mycotoxin concentration, that is something we started this year, really revealed very high variations due to the climatic changes, maybe other factors as well. We try to factor in, we look at all the data for the last 4 years and try to factor in on what may be the potential reasons for that. And in the latter part of 2022, as you can see in the slides I presented, T2, HT2, fumonisin concentration, they started increasing. You can see that very nicely in the diagrams, various charts I showed. And hence, we need to be wary of these mycotoxins in the first half of 2023, because I think many people store these raw materials. They started using them in the first half before the harvesting of the 2023 is coming into picture. The presence of multiple mycotoxins, of course, in feeds demand the solutions with multiple modes of action. And I think that is something we really have to work as an industry together to come up with great solutions. So with that, of course, this presentation was not possible without the help of my colleagues. From Master Lab, Ellen, who is in charge of our MycoMaster, Avinash himself is here today with all the lot of data analysis, and his chemistry background, of course, is really helping us to move forward. The global feed safety team, Marcel being here, Pedro, Guanlin, my colleague, who is a product manager for Toxo, as well, and Pim, who is in charge of our analytical solutions for feed additive team Selko. And of course, the GSS, our team members, quite a few of them contribute to how to digitalize these mycotoxin concentrations we report across the world to make it more user-friendly, coming up with new innovations in terms of mycotoxin advisor, mycotoxin monitor. So with that, Marcel, quite a bit of information, but yeah, I can't reduce it further because it has to be said.
No worries. Thank you so much, Dr. Swami, for your presentation. Luckily, we are still well in time for all the questions that already came in and that actually are still coming in. Just a quick reminder, if you do want to ask a question and you are in the full screen mode, you need to go out of the full screen mode and then you can type your question there, and then we will be selecting some questions to address. So to begin with, you already saw Mr. Avinash move to the screen. You might both need to move a little bit this way, so will you both fit in? Yes.
Yeah.
So Avinash, welcome now to the group. Welcome back. To start with, maybe Avinash, a question for you. We know Swami was explaining about the median and averages. Can you explain a little bit the evaluation on why we should be looking at median instead of average?
Yeah. First, industry normally actually believes, and most of the industry, they use average or a mean in the most particularly. But sometimes, if you look into the data analysis, so always the average is not really good. So because average always helps in a normal data set which is normally distributed. So in case of particularly because it's a real data set and it is not really normally distributed, it's always skewed. So skewed means actually some sort of what you call, there is a outlier of samples because you know that the sample here is sometimes is normally most of the, for example, aflatoxins. So this is a median value around 3 ppb or so something. And suddenly there will be very high level of few samples which are very high level of aflatoxin level that skews. So that is affecting the average.
Yeah.
So that's why. So we feel because the average is not good and always the median is going to be actually a best.
So basically a more reliable way of showing the data, taking out of account these small number of samples that really affect the outcome.
Median is actually a middle value of actually distributing the in a data set.
Yeah.
So because average is actually, again, you know that on, okay, I do not want to explain or to put average.
Yeah.
So that's why I think median is going to be a good, it can be a good parameter to analyze.
Okay, thank you so much. Swami, we are getting multiple questions. We've only selected a few, but more questions related to when it comes to the animal health risk. What is then more important? Is it the percentage of contamination or would it be the concentration of the various mycotoxins?
I think this is a great question because a lot of people get confused with this. Percentage contamination does not matter to animal toxicity. Nothing at all. Because you can have 95% contamination, but all that 95% within the levels that is not causing toxicity to the animals, right? So that's why as veterinarians, when we look at toxicity models, we always look at concentrations. So how many micrograms of the toxin is actually getting inside the animal? Is it 1 microgram? Is it 5 microgram, 10 microgram per day, or, you know? So we calculate that, not on the percentage contamination. I think that's why in our webinar, we always try to make this differentiation because it's very key. Because sometimes, you know, we have 95% of fumonisin contamination. The industry gets scared, right? Maybe out of 95, probably only 50% of those samples are really causing problem. Another 45% are well within the limits that is not causing problem to the animals, right? So when it comes to animal toxicity, it is about the concentrations, and concentrations means what? Like how many microgram of a toxin actually going inside the animal. Let's say a chicken is eating 100 grams of feed, So through that feed, how many microgram of toxin is going inside? So it's very important that we understand that percent contamination doesn't mean anything to the animal toxicity. It only talks about, okay, how prevalent is the problem,
Yeah.
right? It doesn't talk about the animal toxicity as such.
Yeah, yeah, yeah. Back to you, Avinash. There's a question that came in about well, not our, but in general, about rapid analysis. And I've heard with rapid analysis, it's highly dependent on the quality of the sample. But if we take that out of account, would the rapid analysis results be comparable or as reliable as, for example, the HPLC or the LCMS analysis methods?
Yeah, this is a good question. Yeah, because many people ask us actually regarding many times we have seen this question. So of course, the rapid analysis actually, the main purpose of this analysis actually immediately make an awareness of the sample, whether it's a highly contaminated. And of course, if you look into the accuracy of LCM, SMS, you definitely cannot compare. So of course, we can, these results are comparable with ELISA because the technology, both are having the immunological methods. So that's why you can compare, but you cannot, of course. Sometimes, so we have, because it will give a broad idea. So how this is actually, whether it is really a good sample or not, how much bad. So you may not get an exact value, but it will be so a reliable value it can give, so that the farmer can or customer, whoever it can decide, okay, so whether this material can be used or not. So that's why. So this is a purpose actually cannot just compare.
It's actually
Just to add, Marcel, is that, historically we were talking about just the detection, right? But today, even the rapid methodology, there is a quantification. So yes, they are reliable, there is no doubt, but you cannot compare with LCMS or HPLC. And LCMS, HPLC is usually, let's say, a farmer is having a big problem. Hundreds of his chickens are dying, pigs are dying, right? So then you can afford to send them to a lab to the same way look at organs, like histopathology. The same way we send the samples for mycotoxin analysis. It will take at least 4 or 5 days to get the result, even in the fastest sense, right? But if you're sending a sample from Asia to Europe, it might take 15 days. So definitely, each of these methods have a different application. Rapid is good, but we have to take with a pinch of salt whether we know that it is not 100% as accurate as compared to that of the HPLC.
Which is fine because it's a different purpose, right? So indeed, if you really are noticing you have a problem on your farm or in your facilities, that's when you need to invest in investigating what's going on with the other methods as well. Okay.
Absolutely.
Thank you so much. When it comes to animal health and analyzing the samples, is it better to analyze the complete feeds or to check each individual raw material?
I think that's, again, that's something I am promoting quite actively. It depends on this. I think, the industry has been spending billions of dollars, if I can say, on mycotoxin analysis today, easily. So if you have to understand the right purpose of analysis, if you want to quality control issues, right, you want to select this raw material, accept this raw material, or reject this raw materials, definitely you're looking at raw materials, right? Whereas if there is a toxicity in animals, the first place to start with the feed, not the raw material. So once you know that there is a problem, then you can look at, okay, there are 5 ingredients within.
Because you don't know yet if it's a mycotoxin issue. You first start with the feed, and then when you see trouble,
go deep into ingredients, where it is really coming from. Is it maize is the problem? Is it DDG is the problem? Soybean is the problem? Then you can understand. So it reduces the cost of analysis as well. And also it makes sense because a chicken is eating the complete feed, not an ingredient. Right? So I think that more and more people started looking at that way. But of course, in some cases, they don't have time to check the feed first and then do the raw materials. Of course, if you have the capability, if the problem is severe, you do all of them at one time and you will come to know where the problem is coming from.
Speaking of origin, there's a question that came in from the audience. How do we look at the data that is originated in a country, but the actual materials might have a different origin? Is there something we can say about that?
Oh, great question. Honestly, that is somewhere I would like to go. What we have presented today, hopefully one day we can stand here and talk about, okay, this sample came to Thailand from US, you know.
Yeah.
We always requesting our suppliers, our customers, mention the origin of raw material, right? I mean, if they don't give us the information, unfortunately, we will not know,
No.
right? So if they inform us, okay, this sample is actually used in Thailand, but the origin is from US, then of course I will put that into the US, not into the the Thailand number, right? But many times you saw in my presentation about 4,000 samples didn't have any right sample category, right?
Okay.
So we put it in others,
Yeah.
right? So it's important that more and more support from the industry, support from the customers as well, making it more meaningful. I think that ultimately that's what we need to do, where the problem is coming from, not actually where the feed is made per se.
I see. So that's really great to know, that we are also still learning and expanding. Yes. We know also the number of analysis is growing each year.
Yes.
But it's of course important to know where the samples are coming from and what material was tested. At least we continue to improve
this. Sometimes we do get that now, but not for all the samples. And that's really a handicap for us.
Something that we are keeping on improving. Yes. When we are comparing the seasons, Avinash, you saw these variations month by month in the different mycotoxin concentrations. Yeah. Can you explain a little bit on how this can occur?
Yeah, this is actually when because it's more than 50,000 data sets, and this is really, because if you just plot on that one, because it's completely jumble line. So, but when the analysis, it was a smoothing and a regression. So this is a regression modeling. So using that one, because it is giving, because it will take an average and then give a smooth line. So then it's giving a trend, because otherwise you cannot make a sense out of it. So then the monthly wise, because each and every data point is available, and it is making, because how much variation, because it's a seasonal variations and because climatic variations, because how at what time that was analyzed. Yeah. So because it's representing that actually the conditions of that, that's why. So you are seeing that of variations. Yeah. So that is giving at least some sort of maybe you can develop into a further model, and a prediction model can be you can develop on that.
This is also what Pedro was explaining at the start, that we are working on setting up this modeling to hopefully be able to predict the risk. Yes. Instead of having to mitigate the risk when it already is occurring. I can imagine that's a really daunting task, something we are really striving to keep improving.
There are some institutions which have done in Canada, for example. There is a model called Downcast, but something more globally available to the public. I think that's more important. And for that we need number of inputs, which hopefully over the years we will reach there.
Yeah. I see a question coming up, a little bit different topic, about trying to mitigate the toxins. Would a heat treatment be effective when you want to mitigate mycotoxins from the feed?
Unfortunately not. Otherwise, I wouldn't be standing here and talking so much about the innovations, right? Because we do pellet the feed, we extrude the feed. So if it is susceptible to the heat, we wouldn't be talking. Only two toxins, as per my knowledge goes, ergot toxins, citrinine. Those two toxins tend to be a bit more sensitive to the heat treatment. So those levels can come down. But most other mycotoxins, with the available research what we have today, maybe few percent, like 4%, 5% decrease in the concentrations, which is not significant in terms of actually reducing the problem. So honestly, if that was the solution, I don't think would have faced so many problems in the world today.
It would have been, that would be great. So unfortunately, not a number one solution
acid treatment doesn't help. Just to add another thing, if you put an acid inside, a mold inhibitor inside a feed, it doesn't kill the toxin, it kills the fungus. The toxin is still there. The heat treatment doesn't kill, and nothing apart from binding technology, which is actually not killing the toxin, it's taking outside the system. So of course, various other techniques have been developed and developing too.
I see. So if you treat the molds that are producing the toxins, you might reduce the molds, but the toxins that were already there will stay, and you need to have these other methods. Let me see. There's another question about the development of the toxins. At what stage, what stages in the plant growth or in the harvest or in the storage really affect the aflatoxin, not afla or mycotoxin, the different toxin developments? I guess it's different, maybe per.
Maybe Avinash, you want to add a little bit on aspergillus?
Yeah, this is one. There are mainly, for example, aspergillus or penicillium. Mostly, they are all storage fungi. It is called. And as a fusarium, actually it's a soil fungus. So particularly the fusarium mycotoxins are produced because they will invade into the plant during the growth. So during that, and whenever suitable conditions come, they accumulate. So that's why actually you are seeing the seasonal variations in mycotoxin. And of course, for example, now some of the aspergillus and also they also sometimes in some places it may also affect in the feed as well, and during the normal conditions, and also many times in the storage conditions, because when the storage conditions are very humid, so high temperature, then it will lead to the accumulation. So that's why variation will come.
Just to give an example, Mars, you look at T2. T2 is commonly seen more in some parts of the US, Russia, in Eastern European countries, because there the conditions for the T2 fumonisin, Dawn, just to give an example, all are fusarium fungus. But all of them, the genus is same, fusarium. The species is different. The T2 coming from sporotrichids. Dawn comes from Graminearum, and fumonisin come from Moniliforme, right? So all these subspecies of the fungus, they require different conditions. Fumonisin need high temperature, whereas the Dawn needs medium temperature. T2 fungus, producing fungus. But the Dawn, especially what Avinash was telling, especially in the silking phase, when the silk comes out of the corn or the wheat, that phase, if the weather is a bit cloudy, rainfall, you see more of Dawn growing there. So that is why the variation, because if that during that particular window of plant growth, if the conditions are not conducive for the growth of the fungus, then that year you see less mycotoxin.
Is this also why we see this year-to-year variation?
Of course.
Because climate plays a very vital role in that.
And I also think Pedro explained at the beginning a bit of this El Nino effect that we can see. That also would explain why one year it's a flat line, and other years we see more of these fluctuations.
This year, I think if you look into this one, aflatoxin Asia particularly, it is because of monsoon extension of the monsoon season. So that is because we are seeing a very high surge of aflatoxin level. So last year, I think I remember this one aflatoxin level in both Africa, and they are very, very similar. But this year, Asia is giving a higher level.
So when it comes to eliminating or mitigating these various mycotoxins, you already explained briefly, just binding might not be completely sufficient. Can you explain a little bit about the other actions that somebody can take to mitigate mycotoxins in various levels?
Yeah, of course. I think this binding approach or technology is the last part, right? We are going to put that in the feed. But before that, how you are selecting the raw materials, how you are storing the raw materials, how you are producing the feed in the feed mill, what is the hygienic conditions inside the feed mill, how do you transport your raw material, how do you transport your feed, all have an impact. But when it comes to the solutions which are adding into the feed, since science has shown that binding approach is limited for some toxins, we need to look at whether enzymatic detoxification helps, whether strengthening the liver system helps, whether improving the antioxidant status, or can we make the liver more resilient to the challenges. So I think in the coming years you will see beyond enzymatic approach what else is there also. So these are all innovations takes time, but I think definitely they will come into the forefront.
I just saw a question coming in, but it's out of my screen, so I'll wait for my moderator to scroll down just a little bit so I can see it. Oops. Anyway, so yeah, here we go. So what is immune modulation, and what are some solutions, products, or other methods that you can recommend for that?
Well, immune modulation is basically a number of areas, but one thing we have observed is that the macrophages are some kind of cells in the immune system. They're fundamentally very important for all kinds of immune responses, whether it is a better antibody production, whether it is a better virus killing, all these, you need those kind of macrophage activation. And we have found an yeast cell wall product which improve that macrophage activity. So by improving the macrophage activity, you're strengthening the immune system. And we found some correlation with, not just as a general immune modulator, but with mycotoxin exposure. So we expose the chicken or pigs to the mycotoxin, and then we put this immune modulator. Is it reducing the negative effect of mycotoxins on this immune system? So yeah, the number of agents, but what we deal with is some of the yeast cell wall fraction to improve that.
Okay, so it's indeed not just trying to mitigate absorption, but also helping the animal to resist and to really strengthen that gut wall.
Because you cannot take away all the toxins. It's impossible.
Yep. Let me see if I can see some more questions. There's one, actually, I'm not sure if we can answer, but let's try it. Do we have a formula to calculate the challenge if we have a mix of many toxins? I guess it has to do also with the synergy.
I think we are pretty much there. We are doing for poultry already, but we are looking at pigs in the of a phase now. The ruminant is a bit complicated because not many studies out there. Because these kind of things we need to have some scientific basis. You cannot just put whatever the number you want, right? So for poultry and pigs, we have more research, and yes, there are some formulas we can put to come up with that.
Okay. Thank you so much. I think we are ready to conclude today. Of course, if you do continue to have questions, please feel free to address them. On the website of the event, you can also get in touch with us. So if you want any further support or have questions about your particular situation, we are always happy to help you. A big thank you today to Mr. Pedro Carmona, who you saw at the start. Mr. Avinash Bhatt, thank you so much for your technical input. And of course, our main presenter for today, Dr. Swami, thank you so much for being with us today.
Welcome.
And thank you, everybody, for watching, bearing with us during our small technical issue there. Thank you for staying on, and we really hope to see you online for our next events. Thank you.
Thank you.